7.4 is on proving triangles are similar by angle, angle, side, 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 and side, angle, side. So our objective for today is identify if two triangles are similar, and we're going to justify why they are similar. And we're going to construct a similarity statement as well for these. So the first one that we have is side by side, side, side similarity theorem. And this is when the corresponding sides of two triangles are proportional with each other. So we're just going to add the word proportional there. Then the triangles are similar. So this statement right here, this is our proportionality statement. And this statement over here, this is our similarity statement. Okay, so you will need to know the difference between these two for quizzes and tests. So for the first one, we're going to write the proportionality statement for triangle QRS and triangle DEF. So when we're doing this, just like when we had congruent triangles, the order of the names matter. So the first two letters of each triangle represent two sides that are proportional with each other. So when we write our proportionality statement, we can start with QR over DE because these two sides are proportional. Then if we do the second two letters in each statement, we can do RS over EF. And then lastly, we can do the first and the last letter with each triangle name. So we can do QS over DF. One thing you'll notice is these segment lines do not have the symbol of a line segment over it. Another thing, all three of the sides that are listed on top are from the first triangle, and all three of the sides listed on the bottom are from the second triangle. So you want to make sure that they are all on the same part of the fraction. So the first triangle, we're all on top, and the second, we're all on the bottom. Okay, so that was proportionality statement. Next, we are going to try to determine whether or not triangle DEF or GHJ are similar to triangle ABC. So we're comparing both of them to this triangle. So when we're doing that, we're going to start with triangle DEF and ABC. When we're trying to compare the two, I always recommend circling the smallest side on the triangle and putting a square around the largest. And then doing the same thing in our second triangle. By doing that, we know right away just by looking at these which sides are proportional with each other, or which sides need to be proportional for them to be similar. So the circles go together, squares go together, and the ones we didn't circle or square also go together. So our first fraction that we're going to write to see if they're proportional is 8 over 4 with our circles, which simplifies to 2. Then if we do the same thing with our squares, we would get 12 over 8, which simplifies to 3 over 2. So because these two are not the same, then we can say they are triangle ABC is not similar to triangle DEF because the sides are not proportional to each other. Okay. So next, we're going to do the same thing, but this time we're going to compare DEF or ABC with GHI. So again, for this one, I'm going to circle the smallest and put a square around the largest. And then we can set up our fractions to see if they're equal to each other. So if we start with our circles, we can do 8 over 16, which simplifies to 1/2. 12 over 24, which also simplifies to 1/2. So because these two are the same, I need to continue and check that third side on both of the triangles. So this one would be 9 over 18, which also equals 1/2. So to say these triangles are similar, we have to show that these three proportionality statements are equal. So this one, we could say ABC is similar to triangle GHJ, and the Y would be side, 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 because we showed that all three sides were proportional with each other between the two triangles. Moving on to example 3. For this one, we are going to find the value of x that makes triangle ABC similar to triangle DEF. So first we want to choose a side that is corresponding between the two triangles that both have number values, so they don't have a variable with them. So looking at our first triangle, that could either be AC or BC. So if we look at our similarity statement, AC would have to go with DF, which if you look over there, that has an x variable. So we don't want to choose those two to start off with. If we look at our second one, BC would go with EF. So those two can go together. And you'll notice both of those are number values without a variable. So we can start off our fraction with 4 over 10 equals. Now we need to set up the second part. So you can choose AB if you would like in our first triangle, which would go with DE of our second triangle. Then we can put that in a fraction equal to the first fraction that we set up. And you'll notice the 4 and the x minus 3 both came from the same triangle, so they both are on top. Once we have this, we can cross multiply. And don't forget the parentheses around the x minus 3 so that you remember to distribute that part of the problem. So then here we'll take 10 times x to get 10x, and 10 times negative 3, which will be minus 30. We'll add 30 to both sides, which will leave us with 10x equals 110. And if we divide both sides by 10, we will end up with x equals 11. Now, we could have set up a different statement here, or different equation, with the other sides that are proportional to each other as well. So this one, there were a few different ways you could solve it. This is just one example of how to do that. So the next way that we can prove two triangles are similar is by side, angle, side. So for this one, we have to have an included angle, and then we have to show that the two sides around that angle are proportional with each other. If we do that, for the lengths, including these angles are, if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides, including these angles, are proportional, then the triangles are similar. So this is kind of like side, 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 except we only have to show that two sides are proportional instead of all three. So let's do that in an example. We are going to determine if these two triangles are similar. So first, we want to check we have the similar angle. So now, in order to do side, angle, side, we need to prove that the two sides around that angle are proportional. So I'm going to circle the smallest side and box the bigger side, and do the same in our second triangle. In this one, they are on the same sides as each other, but that's not always going to be the case. So circling the smallest and putting a square around the largest will help keep it in order for you so you know which sides have to go together. To check this one, I can do 28 over 16. And these are both divisible by, not 8, 4. These are both divisible by 4. So 28 divided by 4 would be 7, and 16 divided by 4 would be 4. Then we'll do the same thing with our circle side. So we can do 21 over 12. And these ones are both divisible by 3, and we will end up with 7 over 4. So because these are the same, that tells us these are similar triangles. So we can say triangle RTS is similar to triangle XZY. And the reason why would be side, angle, side. We just have 2 more examples to do, and for this one we're going to verify that triangle ABC is similar to triangle DEF. Then we're going to find the scale factor, and we'll go over that after we determine if they're similar. This one we're given all 3 sides, so I'm going to go ahead, circle my smallest, and put a square around my largest side. That way I know which ones go together. Then we can set up our fractions. So I'm going to start with 15 over 10, which would simplify if we divide them both by 5 to be 3 over 2. Then we can go ahead and do the same thing for our circles. 9 over 6, and if we divide these both by 3, we would get 3 over 2 again. Then we're going to pair up our 12 over 8. And if we divide these both by 4, we would end up with 3 over 2. So because all of these are equal, we know they are similar. Then they want us to find the scale factor from ABC. So I'm going to put a from here, and we're going to DEF. So when you're writing your scale factor, and I'm going to use SF to represent scale factor, you put a side length from the 2 on top. So remember 2 top, TT, kind of goes together. And then the from corresponding side on the bottom. So our scale factor for this one, you can choose any side length from the triangle you're going to. So I'm just going to choose 8, which means 8 would go on top. And then on the bottom, I would put 12. And don't forget to simplify your answer. So we would divide both of these by 4 and to get 2 over 3 for our scale factor. Notice our scale factor is not equal to the fractions we found that were proportional. Sometimes it will be, sometimes it won't be. So you always want to make sure you check the scale factor because it's not always going to be the same as it is over here. All right, so if you want to go ahead and try the next one on your own and then press play to see if you got it correct, that would be a good practice to see if you understood the notes. So again, the first thing I'm going to do to go over this, I'm going to circle the smallest and put a square around the largest for both of my triangles. Then I'm going to set up my 3 fractions. So for this, I'm going to put 18 over 24. And if I divide both of these by 6, I would get 3 over 4. Then I can do 33 over 44. These are both divisible by 11, which would give us 3 over 4 as well. And my last 2 sides to go together would be 21 over 28. And if we divide these by 7, we would get 3 over 4. So these 3 are the same. If one was different, then they would be not similar. But these ones are all the same, so we know they are similar. think I added an extra I there. Sorry about that. Okay, so now because they're similar, we can find a scale factor. If they are not similar, you do not write a scale factor. So again, we're going to DEF and we're coming from ABC. So for my scale factor, I'm going to put 44 over 33. And again, these are both divisible by 11, so I can get 4 over 3 as my scale factor. All right, so if you got any of that a little bit mixed up, make sure you fix it on your notes. And if you have any questions on this section, just let me know.